Okay, in number 20, we are going to have this function. We're going to find the amplitude in the period, and then we're going to graph. So first things first, the amplitude is going to be the a value out in front of the function. So my amplitude is 2. So to help me later with graphing, I'm going to go ahead and label one positive 2 and then negative 2 because that is where my graph is going to go between. And then to find the period, you have to memorize the formula is always 2 pi divided by b. Your b value is always the number in front of x. So my b is 4. So it's going to be 2 pi over 4 for the period. And that's going to be, when I simplify, dividing 2 top and bottom, pi over 2. So the period is going to be pi over 2, and my amplitude is 2. And so I'm going to go ahead and 1, 2, 3, 4, 5 points that I'm going to be putting on this graph. And the period is going to be pi over 2. So that's going to take me through one of my sine cycles here. So what I want to do is I want to plot points for the sine. So I'm going to do this first, and then I'm going to take the 5 points and I'm going to translate them down 1 after. So we won't forget to do that. All right, so I'm going to first do this part on my graph. So with the sine graph, we want to remember that that is going to cross through 0, 0. So I'm going to put a point at 0, 0, and what I'm going to actually do on this one is I'm going to use a pencil because it's not my final answer that I'm about to graph, again, because I'm going to be translating down 1. So with the sine graph, it's going to pass through 0, 0, and then go up here. We didn't label those, but we can go ahead and do that. 3 pi over 8. Okay. And then we're going to go back down pi over 4. So remember that the way I taught it was you're going to have 5 points. So you always have something on the y-axis, and then 1, 2, 3, 4, 5 points. And that would be the period, always at that 5th point. So what I did was I divided that period in half, divided that in half, and then I counted pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and then 4 pi over 8, which is pi over 2. So in the sine graph, we always have it 0, 0. Then we're going to go up to pi over 8, and then we're going to go back down, and that's going to pass through the x-axis at pi over 4, and then we're going to continue to go down to negative 2. I should have written that a little bit smaller, sorry. 3 pi over 8, and then we have a point down here at negative 2, and then it's going to bounce back up and pass through pi over 2. So our sine graph does this, and it is going to go on infinitely. We're just going to draw this one through one period to start. So this would be that graph if I connected those dots, drew it infinitely, but that is not our answer. We do have to take all of those points and translate them down 1. So I take this, it goes down 1. This goes from 2 to 1, down 1, and then this is going to go down to negative 3, and this goes down 1 to 1. So what I would do now is I would go back and erase what I had up here in pencil because that is not my answer. That just helped me get to my answer. So those other points in graph I erased, and then this is going to be that sine 2 sine 4x minus 1. And then we do want to draw that going infinitely in both directions. Whoops. Sorry. And it does that. So what we do want to understand with this sine graph is that it's periodic. It's going to go on infinitely, and it's going to bounce back and forth between these numbers here. So because it shifted down, it's going to bounce between +1 and -3. So just know it'll never cross through those. It has to stay between. Okay. Number 21, we're going to consider this right triangle and determine whether each expression So these expressions right here can be used to find the length of PQ. So PQ, I'm going to put an X right there, and essentially we're looking to solve for X using the different functions. They use sine of Q, cosine of Q, sine of P, and tangent of P. So we're going to mark yes or no for each one, and what we're going to do is we're going to make sure that we understand how this triangle, like how to read it, like how the sides are labeled. So we should understand that this is our hypotenuse. The X is going to be our hypotenuse, okay? So depending if they ask us for sine, cosine, tangent of Q, if they ask us for Q, then hopefully we understand 8 is opposite and 15 is adjacent. And if they ask about finding functions from P, then 15 is your opposite of P and 8 is adjacent to P. And then of course, X is always the hypotenuse no matter if they talk about angle P or angle Q. So what I'm gonna do, sorry this box looked like this, how weird. I don't know why my printer did that. Okay, so the first thing we're gonna do is we are going to, well, let's talk about SOHCAHTOA for a second, because you have to know the sine function, cosine, and tangent to do this problem. So remember, sine means opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent is, why did I do that? It is not 10 o'clock at night right now. Okay, and then TOA is tangent means opposite over adjacent. Okay, so what we have is first, we want to know if 8 over sine Q is going to help us solve for X. So I think the easiest way to do this, you guys, is to look at sine Q and find sine Q. Write that ratio or that fraction. So I'm going to write sine of Q, okay, equals, and I know sine means opposite over hypotenuse. So what I'm going to do is I'm going to look here at my triangle. Here's Q, and I'm going to write the equation, or not the equation, the fraction or ratio for sine of Q. So that's going to be sine means opposite over hypotenuse. So 8 over X, opposite over hypotenuse. So 8 over X is my ratio. So what this whole point of this is to figure out how to solve for X. What is it going to look like? So what we're going to do is we're going to put a 1 underneath here, and we're going to cross multiply. So when I cross multiply, 1 times 8, or let's do X times sine Q. It doesn't matter which way we go, but I'm going to do X times sine Q is equal to 1 times 8, which is 8. And then to get X by itself, you're going to divide away sine Q to both sides. And you get X is equal to 8 divided by sine Q. And that is exactly what we have, 8 divided by sine Q. So I'm going to check that one. This is a expression that could be used to help me find X, to find that missing side. Okay, so now we're going to move on to the second part. So that was only part 1, and we decided yes. So let's look at part 2. Now we're focusing on cosine of Q. Is 15 over cosine Q going to be an expression that solves for X? So what I'm going to do is I'm going to write the ratio for cosine Q. So let me go down here. Cosine Q, remember, cosine means adjacent over hypotenuse. So now we're on Q. Adjacent is 15 and hypotenuse is X. So it's going to be 15 over X, adjacent to Q and hypotenuse. So again, we put a 1 underneath, cross multiply. X times cosine Q is equal to 1 times 15, which is 15. And then we're going to divide cosine Q to get X by itself. And I get X is equal to 15 divided by cosine Q. And that's exactly what they have right here. 15 over cosine Q is going to help us solve for X. All right, third one. We're going to see if 15 divided by sine P gets us X. So I'm going to write my ratio for sine of P. So remember, sine is opposite over hypotenuse. So if P is here, opposite is 15, hypotenuse is X. So 15 over X is going to be my ratio. So I'm going to cross multiply, and I get X times sine P equals 15, right? 1 times 15 is 15. I'm going to divide by sine p to get x by itself. And x is equal to 15 divided by sine p. And again, that's exactly what they give us here. So we're going to say, yes, that is an expression to solve for the missing side, to solve for x. All right, and then the last one, 8 divided by tangent p. We're going to see if that is going to work to solve for the missing side. So I'm going to show tangent p. Tangent p, we know tangent means opposite over adjacent. So here's p, opposite is 15 and adjacent is 8. So it's going to be 15 over 8. So there's nothing that you can even solve for x right here. It doesn't even include the missing side. So that is not going to work. Okay, we're given the point -4, 3 lies on the terminal side of angle theta in standard form position. So if we want to draw that in standard form, if this is 0, 0, we go -4 and then up 3. That would be somewhere right here in the second quadrant. So this would be -4, 3. And that is going to be in our standard form position. And that would mean -4 would be the side length here, and 3 would be side length here, creating a triangle. So we know it goes x, y, so -4, 3. So what I'm going to do, because they're asking us then to evaluate the 6 trig functions of this, I'm going to actually take that triangle and just draw it a bit bigger for us. So this is, again, oh, we should label that theta, by the way. It's always our reference angle, the angle formed here with the, next to the origin, I guess you could remember. So that's our theta. This is -4 and 3. So if I'm going to find the 6 trig functions, I'm going to need this hypotenuse. So what I'm going to do is put an x there, and I'm going to be using the Pythagorean theorem. So we want to, again, remember that A and B are the legs in the right triangle, interchangeable, but your hypotenuse is always the C in the equation. So I'm going to do 3 squared plus -4 squared is equal to x squared, and then we're going to solve for x to find that missing side. So -4 squared is positive 16, and I get 25 equals x squared. So to solve for x, I do the square root to both sides, and the square and square root cancel out, and I get my hypotenuse has a length of 5. All right, so now we are going to evaluate all of the 6 trig functions. So we have sine of theta. Again, I'm going to write down SOHCAHTOA. Okay, and then I taught you guys that you match up the first 3 with the second 3. Cosecant is going to be the reciprocal of sine. Then secant will be the reciprocal of cosine. And then cotangent will be the reciprocal of tangent. Okay, so if this is theta, we have to understand that this side is opposite, this is adjacent, and this is our hypotenuse. So we can create those ratios. Sine of theta is opposite over hypotenuse, so 3/5. Cosine of theta means adjacent over hypotenuse, so -4/5. And then tangent of theta, tangent is opposite over adjacent, so 3/-4 is our tangent. All right, then we need to write the other 3. Cosecant is just the reciprocal of sine, so 5/3. And secant of theta is the reciprocal of cosine, so -5/4. And then cotangent theta is the reciprocal of tangent, so -4/3. Okay, and those are our 6 trig functions that we evaluated. Number 23, we're going to evaluate the following trig functions without using a calculator. So you'll be using your special triangles. Okay, so sine of 60 degrees, we know sine is going to be opposite over hypotenuse. Some of you have memorized sine of 60 degrees and you know that it's positive square root 3/2. But for the rest of us, let's just look at putting 60 degrees that would be between 0 and 90. So 60 degrees would be about here. And then if we create that triangle, the 60-degree reference angle is here. So if this is 60 degrees, then this angle here is 30. Okay, I'll draw bigger next time. All right, so if this is the reference angle, then we know this is opposite and this is hypotenuse, and those are the side lengths we need. So we remember in the 30, 60, 90 triangle, always the side across from the 60-degree angle is square root of 3. It's positive square root 3 because this side goes up. So positive square root 3, and then our hypotenuse always in the 30, 60, 90 triangle is positive 2. So sine of 60 is equal to opposite over hypotenuse. So it's positive square root 3 over 2. All right, cosine of 30 degrees. Let me try to draw. Okay, so this is 0. I made that a little bit too big. And this is 90 degrees. So 30 degrees is going to be about right here. And then if we draw that triangle, here's our reference angle, 30 degrees, because 30 minus 0 is 30. So that's our 30-degree reference angle. So this has to be 60 degrees, and they're asking for cosine. Again, some of you have that memorized. Cosine of 30 degrees is always square root 3 over 2. But if you didn't, that's why I'm drawing this for you. If they want cosine, we know they want adjacent over hypotenuse. So across from the 60-degree angle here is going to always be square root 3. It's positive because I'm going to the right. And then your hypotenuse in the 30, 60, 90 triangle is always positive 2. So cosine of the 30 degrees is adjacent over hypotenuse, or square root 3 over 2. Okay, cosecant of 45 degrees. We want to remember that cosecant is just going to be 1 over sine, or the reciprocal of sine. So it's going to be, if you guys want to write this down, sine is opposite over hypotenuse. So we know cosecant is going to be hypotenuse over opposite. So what I'm going to do is I'm going to find sine of 45 degrees, and then I'm going to do the reciprocal of that fraction. So this is 0, this is 90, so 45 degrees is going to be right here, again in quadrant 1. And that is going to form a 45-degree reference angle. So it's a 45, 45, 90 triangle, and we remember that always the legs are going to be 1. They're both positive because of this going to the right and up, which, by the way, I only needed the opposite. I didn't need the adjacent. So I don't know why I wrote that. Opposite is positive 1, and then hypotenuse is always positive square root 2 in the 45, 45, 90. So if I find sine, it's opposite over hypotenuse. So it'd be 1 over square root of 2. So cosecant is going to be the reciprocal. So it's going to be square root 2 over 1, which is square root 2. And then part D, tangent of pi over 6. We want to remember that pi over 6 is 30 degrees. So we're looking for opposite over adjacent to figure out tangent of 30 degrees. So again, some of you have that memorized, but we will draw anyways. Tangent of 30 degrees, this is 0, this is 90, so 30 degrees would be here, and that forms a 30-degree reference angle because 30 minus 0 is 30. This has to be 60 then, and then we're looking for opposite over adjacent. So always across from the 30-degree angle will be 1. It's positive 1 because we go up, and always across from that 60-degree angle is square root 3. It's positive because I'm going to the right. So tangent of pi over 6, or tangent of 30 degrees, is opposite over adjacent, so 1 over square root 3. But we can't leave our answer like this. We're going to rationalize by multiplying square root 3 top and bottom, and I get square root 3 over 3. Because it's 1 times square root 3, you don't write the 1 out in front. You just leave it as square root 3, and then square root 3 times square root 3 is square root 9. Square root of 9 is 3. So that's tangent of pi over 6. And then cotangent of pi over 3, we want to remember this means cotangent of 60 degrees. So cotangent really means 1 over tangent. So what we can do is we can find tangent and then just do the reciprocal. So we'll find tangent of 60 degrees and then do the reciprocal, that'll be cotangent. So let me draw the 60 degrees. So here, and then this is 0, this is 90, so 60 degrees is here. And then that's a 60-degree reference angle, so this has to be 30. And if we want tangent, we want opposite and adjacent. Always across from the 60-degree angle is a positive square root 3, and always across from the 30-degree angle is a 1. So tangent of 60 degrees would be opposite over adjacent, square root 3 over 1, but we want cotangent, so we're going to do the reciprocal. So it's 1 over square root 3 for cotangent, but then I'm going to rationalize, and I get cotangent of 60 degrees is square root 3 over 3. All right, in number 24, we're going to find one positive and one negative angle coterminal with the given angle. So we remember coterminal means it lies on the same place in the unit circle. It's just gone around 360 degrees, either by adding or subtracting. So what we want to know is that if I want the positive coterminal angle, I'm going to take negative 590 degrees and I'm going to go around the circle by adding 360. So I have negative 590, I'm going to add 360 degrees. And since these are different signs, I'm going to subtract and keep the sign from the larger number. So that's going to give me 230 degrees, but it's still negative. So since it's still negative, I have to add 360 degrees again. So again, different signs, I'm going to be subtracting and keeping the sign from the larger number, and I get finally positive 130 degrees as my positive coterminal angle. So if I want to find the negative, you actually already have a negative coterminal angle. It's negative 230 degrees. That is because it does lie on the same place in the unit circle. But I know a lot of kids just like following the same procedure. If you want negative, subtract 360. So if you don't want to use that as your answer, which that is totally okay, you can subtract. You're actually adding because they're both negative, and you get negative 950 degrees. That is also a negative coterminal angle. So again, to get your positive, make sure that you take the number and add 360, but you have to add it again until the number is positive. Okay. Number 25, we're going to convert 29 pi over 9 to degrees. So we want to remember that if you want to convert to degrees, you're going to multiply by 180 degrees over pi because you want to bring in the degrees and divide out pi. So the pi's are going to cross cancel out, and you're going to multiply across 180 times 29. That's going to give us this. Placeholder 2 times 0 is 0, 3 and 5,000. So multiplying across 29 times 180 degrees gives us, I'm going to write it down here, 5,220 degrees over 9 times 1, which is 9. So now I'm going to take 5,220 and divide by 9. 9 doesn't go into 5, but 9 can go into 52 5 times. 9 times 5 is 45. I'm going to subtract and get 72. That goes in 8 times, 72, and then 0 divided by 9 is 0. I get 580 degrees. So you want to memorize that to convert to degrees, you need to multiply by 180 over pi. And then after you do that, you have to simplify, which is dividing by the denominator. Okay, so we're given the angle 11 pi over 6. We're going to draw this angle in standard position. So I know 11 pi over 6, if I use my unit circle, is about over here. and this is 12 pi over 6 or 2 pi. Another way we can do this is just go ahead and think about this in degrees. 11 pi over 6 is 330 degrees. Again, using your unit circle if that helps. So 330 degrees and then 360 degrees, that is going to create a reference angle. So this is part A, just drawing it in standard position. Part B, finding the reference angle is the distance to the x-axis, or always created with the x-axis. So if you look at your unit circle, this is 2 pi or 12 pi over 6. So the difference between those are pi over 6. Or if you want to think about it in degrees, 11 pi over 6 is 330 degrees. And then this would be 360. And the difference between them is 30 degrees. And so 30 degrees that's formed between those, we would have to give our answer in radians. They provided the angle in radians, and 30 degrees 6. Okay, part C, we're going to evaluate cotangent of 11 pi over 6. So what we're going to do is we're going to write in the reference angle. I think it is helpful if you write in the reference angle in degrees. So it's a 30-degree reference angle. And then you draw your triangle. They want us to find cotangent. So what I'm going to remember is that that's 1 over tangent. So what you do is you're going to find tangent of the reference angle, and then you're going to do the reciprocal. So we're finding cotangent of 11 pi over 6 or 330 degrees. So tangent is opposite over adjacent. So across from the 30-degree angle is going to be a -1. So across from the 30-degree angle is always 1. It's negative because it goes down here into the 4th quadrant. And then this has to be a 60-degree angle, and across from the 60-degree angle is always square root 3. This is positive square root 3 because I'm going to the right on my adjacent side right here. So my tangent of this would be -1 over square root 3, because tangent means opposite over adjacent. So that would be tangent. So then cotangent of 11 pi over 6 or 330 degrees would be the reciprocal of that. So it would just be negative square root 3 over 1, which is just negative square root 3. So that's your answer for cotangent of 11 pi over 6. Okay, given the angle 225 degrees, we're going to draw that angle in standard position. So we know 90 degrees is here, 180, 270, so 225 is going to be here in quadrant 3. So 225 degrees, and then we are going to, for part B, so that's our answer here, we're going to then find the reference angle. So the reference angle is always formed with the x-axis. So we're going to subtract 225 and 180, and that will give us a 45-degree reference angle. Okay, so if they are giving us the angle in degrees, we'll give them the reference angle in degrees. So it's a 45-degree reference angle. So we're going to evaluate cotangent of 225 degrees. So we're going to go ahead and go here and then draw the triangle. And then this is a 45-degree reference angle. So this has to be a 45, 45, 90. And if they want us to find cotangent, then we are talking about 1 over tangent. We're going to focus on tangent, and then after we find tangent, we'll do the reciprocal. So tangent of 225 degrees is going to be opposite over adjacent. So we're looking at opposite and adjacent. In the 45, 45, 90, the legs are always going to be 1. So across from this 45-degree angle, it's -1 because I'm going down into the, down over here in 3rd quadrant. And then my adjacent is also negative because it's going to the left on this x-axis. So my tangent is opposite over adjacent. So -1 over -1. And so my cotangent, which is the reciprocal of tangent, is going to be just -1 over -1. because the reciprocal is -1 over -1, which is +1. So cotangent of 225 degrees is +1. Okay, so in number 28, we're going to convert 480 degrees to radians. So we are going to remember that to convert to radians, we're trying to get rid of degrees and bring in the pi. So that's why we multiply by pi over 180. So that's just something you need to memorize. Always multiply by pi over 180 degrees if you're converting to radians. So we'll put a 1 underneath and multiply across our fractions. 480 pi over 1 times 180, which is 180. And these degrees canceled. So what I'm going to do now is I'm going to divide out 10 to the top and bottom just to reduce this fraction. So crossing out 0 top and bottom, when I divide by 10 top and bottom, leaves me with 48 over 18, 48 pi over 18. So then I'm going to continue simplifying. I'm going to divide out 6 top and bottom. 48 divided by 6 is 8, and then that's going to give me 8 pi on the top, and then 18 divided by 6 is 3. So I get 8 pi over 3 for my radians. Last question, number 29, we're going to consider this right triangle and then determine whether each of these equations is correct by selecting yes or no. So sine of A equals 12 over 5. Let's see if that works. So here's A. Sine, if you guys want to write this down again, SOHCAHTOA, sine means opposite over hypotenuse. So sine of A would be opposite, which is 12 over hypotenuse, which is 13. So sine of A is 12 over 13. They put 12 over 5, so we're going to check no, that is not correct. Now we're looking to see if cosine A is 5 over 13. So here's A. Cosine is adjacent over hypotenuse. So cosine of A is 5 over 13. So adjacent over hypotenuse gives us 5 over 13. So that is correct. We're going to mark yes. The next one, sine B is 5 over 13. So let's see if this is B. Sine means opposite over hypotenuse. Opposite of B is 5 and hypotenuse is 13. So sine of B is 5 over 13. And that's what they wrote. So my answer is yes. And then cosine of B is 12 over 13. Let's look to see cosine of B would be adjacent over hypotenuse. So 12 over 13. So my answer will also be yes here.